I created a small web application called RGfSEM, which means RGB for structural equation modeling. This is one of the videocasts which belongs to a series of demonstrations related to performing structural equation modeling using R programming language. And this web application is performing structural equation modeling using this web application is far more easier compared to some of the standard applications available in the industry, such as SEM. And to download this application, just go to github.com/Kamakshaya, then click on RGfSEM repository, and here you can just clone or download. You will be provided with a link to download the zip file, and this is there is a file called RGfSEM.R. This is very important. Once you download these files in your computer, just right click on your in your folder and go to the location such as this, and then right click on like this. You'll find right click on the file, then open in the RStudio, and the file will be shown in the RStudio, and it's already open in my RStudio. Now when you open this file in the RStudio, the script file is visible at the left top corner of the. This is how RStudio looks to be. This is how it looks. The left top corner you have the script file, and just right side of the left top window partition in the RStudio, you have a little button called "Let me close my application." So there is a run button with the name "Run App." You just have to open that, press on that button, and now your application will be opened in the browser, the default web browser application the browser application in the RStudio itself. In case if you choose to open this in your default web browser of the operating system, then you have to press on the open in browser, then it will be taken to the web browser of your default web browser application of your operating system. Now I'm going to close this, and let me go back to this RStudio web browser. This is a web application, server level web application, which means it can be installed in the desktop computer or operating system. It can also be deployed across the network so that everybody within the network can make use of this application. Now, in my previous video, I've shown you how to upload the datasets and perform some statistical analysis. In the second video, third video, I explained how to perform the EFA along with the CFA, and this is the fourth video, or perhaps the fifth video. I don't know the exact number, but I'm going to show you. I've explained how to perform the confirmatory factor analysis and obtain the structure diagrams. We call it the SEM diagram or SEM plots, something like that. It is none other than a path diagram for the proposed structure in the software. In this video, I'm going to show you how to compute the mediation effect, not the moderation. I'm sorry. So, because today people are very crazy they crazily talk about different things when the structural equation modeling is under focus. I told you how to upload the data, perform the analysis, and obtain the plots. And in this video, I'm going to show you just mediation analysis. Okay, I'm not going to talk about rest of the things. In my previous video, I've shown you that you need a text file to write, because this is our programming language in which we have a wonderful mechanism to propose the model by writing the code. It's very, very, very simple. I do feel many times that the audience feel it a bit difficult whenever I ask them to write or read, but they are very happy to drag and drop the boxes and ovals just like in Amos. But to me, that is not so. That is an immature way of performing the analysis. To me, defining the model by writing the code is more meaningful. I don't know. It is a personal opinion, but the different people feel differently when it comes to the individual aptitude is different when it towards software. Now, in my previous video, I've shown you how to define simple models. Like left side, we need to put the latent variable, and this is the notation we use to define the relationship between the LHS and RHS. In RHS we have the manifest variables. The meaning of this statement is that the latent variable f1 is being explained by through x1, x2, x3, something like this. Okay, this we've done in our previous exercise, and this exercise I'm going to show you how to test the indirect effect, direct effect and total effects. There are three different types of effects, and you want some documentation, you can read. There is a lot of mediation. David A. Kenny, he had really written a mind-blowing documentation for this mediation analysis. There are some sections you can study here. What is the direct effect, indirect effect, total effect? Somewhere you will find the expression like, this is the total effect is the direct effect plus indirect effect. So we are be mindful that we are doing cause and effect analysis. This is a high level analysis in research. Perhaps the most important requirements today for in academics for the theory building, theory testing, model building, model testing, something like that. There's a lot of crazy words or phrases in the academics. Structural regression model is one of the default statistical analysis expected by the institutions from the research candidates. This application is far better compared to AMOS, because the entire performance model of this application is upload, perform, uptime. These are the three important steps to perform the structural regression modeling through this app. Now study all this material. If you don't know what is the mediation effect, you can just come here, and there are also statistical tests, but we'll be using the default JET test instead of Sobel test. I may cover this Sobel test in any one of the other videos, but for time being we'll be using the JET test instead of the Sobel test. Sobel test is very robust test to test the mediation effects. You read this, go to this link, and I'll try to furnish this link in my video description, and try to understand what is the mediation effect in. Now let me explain what is mediation effect. Suppose in our exercise, in our data, we have three latent variables, f1, right, f2 and f3. In my previous videos I've shown you how to fit the linear equations for these latent variables and test that model through confirmatory factor analysis or structural equation modeling. Now if I assume that f1, f2 has some cause and effect relationship, and here these are, since latent variables, I have to cover them in ovals, and this is going to be the arrow. And now I can assume that perhaps f3 is going to be a mediator variable. So when if we happen to introduce this variable in between f1 and f2, and the fit measures, or the estimates, so calculated as a result of these relationships, can have some certain significant effect in the study. If I assume that the direct effect as A, the effect between the f1 and f2, f1 is the cause and f2 is the effect, something like that. Like if I imagine f2 is the satisfaction and f1 can be attitude, something like this. Now if the direct effect is A, for any two given indirect effects B, C, now the A tend to become 0. If the effect A becomes 0 when we introduce f3 between f1 and f2, and the multiplication of these two estimates going to make A as 0. This is what is called the 0. This is what is called the mediation effect. So given that some certain situation, it is possible for us to say that f3 is trying to play mediation role. Okay, now how are we going to do this analysis using this RGfSEM web application? It's very simple. We just need to define the model. So we already have f1 as defined x1 plus x2 plus x3. I'm sorry, my my scribe is not good, my handwriting is not good, and f2 as something like this, yeah, y1 y2 y3, and f3 is going to be z1 z2 z3, something like that. Now, so do you remember, this is f1, this is f2, this is f3, okay, f1 f2 f3. Now how am I going to define the model? This is A, this is B, and this is C, right? Now my direct model, my direct effect, which is A, is going to be between F depends A, A can be explained through A multiplied F2, isn't it? That is how we define our models in our earlier exercises. This is F1. Now F1, this is the arrow, right? Arrow always takes from the dependent variable to the independent variable, something like that, or the cause to the effect. Cause to the effect, something like that, or effect to the cause, something like that. See, this is unlike the structure. The structure, the structural equations. In structural, this is the causal equations. The model equations. In regression, what happens? This is the other way around. In regression, we are going to take the arrow like this. This is x and this is y. But whereas here it is different. This is x and this is y. Something like this. This is the effect and this is the cause. Now f1, same f1, going to be b times f3 and f3, and now f3 is going to be c times f2. So this is what is going to be the definition of this is how we define the model. I don't know how to, oh my god, something now at the end, I don't know how to, okay, at the end we are going to define the, so now do you remember, I think, I'm sorry I disturbed this, I think now it is okay. Now let me go down. Now the indirect effect is going to be the BC, so we call it as indirect effect, but in here, till here you are okay. We are going to use a notation is equal to tilde to define this relationships between the manifest variables and to define these latent variables. But for indirect effect, we have a particular notation called colon is equal to, followed by is equal to symbol. Now B times C. This means the software try to understand that we are trying to request for the indirect effect, and now the total effect, you can simply call it as total is equal to A plus B multiplied C, something like this. That's all. We are done with our definition of the model definition. So this is why. So here this one I covered in my last video, and this is the new thing in this video. So I recapitulate once again to do the mediation analysis. Given some 3 mediator variable, here in this situation f3, in this context it is f3. We need to be very clear about the estimates across these relationships, or for these relationships. The direct effect is A, indirect effect is B, C. Now f1, which leads to f3, is going to be defined in this way. Sorry, I think f1 f2, yeah, direct effect f1 f2. If we want to define the relationship f1 comma f2, f1 is equal to, here there will be tilde. Okay, I am not so serious in writing but you have to be very particular about. Now A times f2, right? That is how we define the relationships. Now f1 same f1, B times f3, and now f3 C times f2. Now B C defines the indirect relationship and A is the direct relationship. So the total effect is equal to direct relationship plus indirect relationship. This is what is the way to, this is the way to define the model for our analysis. Now let's back to our So let me copy the same thing here. I can choose to I can define my relationships. This is going to be the mediation, and now I can come up with F1 is equal to A times F2. This is a direct relationship, so it's better to go for direct effect. And SEM F1 is equal to B times F3. You should be very clear about the factors, otherwise you will end up with, and F3 is going to be F3 as defined through C times F2. So you just have to blindly follow the. Now indirect effect is going to be BC. Please be cautious, colon is equal to, this is how, otherwise you end up with B multiplied by C. Now direct effect is going to be, total effect is going to be total is equal to A plus B multiplied C. That's all. Let's see, save, and now go back to the application. Here I think we have the data, right? No, we don't have the data. Let's go to the data, SEM data. We are working with the same data set, x1, x2, x3, y1, y2, y3, z1, z2, z3, something like that. Now CFA, upload the SEM model, and then A plus in total. Yeah, you see, I told you I forgot the colon. Now once again I saved it, once again upload this. Wonderful. Now if the R gives you an output, it simply means that it identifies the model, but not exactly, but it is possible for us to get the output. Now you see it is not that good in terms of the fitness. This is the value of the objective function. This is the p-value for the chi-square statistic. P-value is 0.014, which shows that the chi-square value is significant, and chi-square value happens to be significant if the differences is not minimum between the sample covariances and population covariances. And you just have to study the fundamentals, or you go through my previous videos. Now let me request the CFA summary. Oh, that's so great. Like you see, we got all model perhaps identified. If the model is identified, then it is possible for you to get the summary. If you get NA here instead of some valid numbers, it simply means that your model is not identified. Now let's go down bottom of the analysis, and here you have the indirect effect, and estimate for the indirect effect is 0.004, which is not statistically significant. Now let's go back and see. Do you remember we defined the indirect effect between F1 and F2, right? So indirect, let me take back to the, where is the indirect effect speaks about the relationship between F1 through F3, F1 to F2 through F3. That is indirect effect. Now let's go back and pick up what is the effect between F1 F2, that is minus 0.31, and what is the effect between, effect in the sense estimate effect, both of them are same. These are nothing but covariance or beta values, just like we do in regression. F1 versus F3 0.07, F3 versus F2 0.051. Now F1 versus F2, this is what is the direct effect. Now let's go here and see BC, which is we need to, I'm sorry, I forgot what was the direct effect in our previous because we need to have the two different values. So this is actually okay. Let us perform first. Okay, let me explain you. See, you remember the direct effect is A and indirect effect is being explained through B comma C, right? So now from the analysis, this is the direct effect, the estimate between F1 comma F2. This is A. Oh, it is very clearly mentioned here, right? This is A, this is B, and this is C. Now with the presence of B comma C, which are not indirect effect is not significant, we will come back here. The direct effect is minus 0.315. Okay, now let us do this analysis without an effect, by deleting with a simple model like this, without having without defining the indirect and direct effects. Let us perform this assuming that there is no mediation in the analysis. Now let me pick up this model and okay, not this one. Now you see the direct effect, the estimate between F1 comma F2 is minus 0.566. Now do you remember the previous value? It was minus 0.366, something like that. So let me go back. Remember this value, minus 0.566. Now let me go back to this. Now you see minus 0.315. Earlier 566, minus 0.56. Now it is. So there is a little reduction in the value because minus 0.566 is lesser than minus 0.315. There is a little reduction. However, it is already 0. So we don't have anything new to explain by simply assuming that F3 is mediating between F1 comma F2. So this is how we are going to conclude after performing mediation analysis. And moreover, coming down, you look at the indirect effect, the estimate is 0.004, which is 0. It should be close to 1, right? So that it can be so that the direct effect is not 0, it is less than 0. So we don't need to struggle enough that there is a mediation effect. Moreover, that effect, after assuming that F3 is really am I right? Is this F3? Yeah, F3 is a mediation. F3 as a mediator variable is not impacting the relationship between F1 comma F2 significantly. Okay, the indirect effect is not statistically significant. So this is how we are just going to perform the mediation analysis through structural equation modeling by using confirmatory factor analysis through my web application RGfSEM. I think that is enough for now, and the only thing left are we can do quite a lot analysis in structural equation modeling, just like multi-group analysis, hierarchical structures, parallel structures, etc. There's a lot of and we can also, this is actually, we performed the JET test to test the indirect effect between F1 and F2, but there is another test called Sobel test. That's a more robust test. Unfortunately, Lavan has not that test in it. So I can also talk about that test later in my future forthcoming videos. For time being, this is sufficient. This is sufficient for normal academic research, or as well as corporate research works. In case if you would like to make the reports, you just straight away copy paste this information into the Word files and then go ahead with your reports. Thanks for watching my video, and if you like my video, please press like. Stay tuned for the new content. Thanks a lot.